point of contact is this one. There exists also B1. For B1 also there exists center of mass. Hello, today we'll see the basic portion of dynamics. That's about impact. Here, impact is most of the time when two bodies hit each other, or when two bodies collide each other. When two bodies collide each other. When two bodies collide each other, due to collision, right? Due to collision. That means because of the two bodies motion. For example, take two particles. For example, this is the first particle. Say it is as one ball. One ball we can consider it. And there is a second ball we can consider it. For example, there is a person who plays ball here and kicks here this way, and there is a person also kicks here. Somewhere they collide at one axis. They collide at some center. Okay, they becomes in some contact. That means after a time being they will be at some contact, and that contact line is obtained or created. That contact line is created. How can we express that contact line? How can we express? For example, take it. It becomes like this. There is a contact line this way, or we are seeing the side look or 2D view. But if you see in that direction, imagine it is created the like plane like this, right? Plane like this is created. That is called the surface. We can say the contact surface. This side there exists the first was one particle, and another side there exists another particle. So collision is created at this line, but if you consider the plane, it is at this plane. Consider the two particles who have, for example, that we have assigned the first one and second one, ball 1 and ball 2. See, if ball one has its own center of mass, or somewhere like this you can consider its own center of mass. Ball B also has primarily its own center of mass. After contact also there exists ball 1 and ball 2 center of masses, right? Center of masses. See, there is a point or a line that's joining the center of masses of the two balls. The center of masses of the two balls here. For example, we can consider like this. This plane plays this one. For example, there exists one ball in this place. It has a center of mass at this point. So a line created between the two balls contact and the center of mass of the ball 2 here. In another side also there exists ball 2. Sorry, ball 1. So the contact line, this ball 1. The contact line there is, for example, it is as per my drawing. I am drawing the oblique view. For example, I can arrange this one. The placement arrangement of this one, I can arrange it. So like this. For example, the center of mass exists here around this way, because oblique view I am drawing. I told you oblique view. So the line of the place contact or point is this one, and the center of mass of B is this line, this point. So a line created in the joining in between center of mass and the point of contact is this one. There exists also B1. For B1 also there exists center of mass somewhere in here we can consider. So there exists the line, the point that joins, that can be joined from the center of mass of B1, center of mass of B1 and center of mass of B1 and the contact line or contact point, I can say contact point. Okay, contact point. And the third point is the center of mass of B2. So this line is called line of contact, line of impact. This line is called line of impact. We can say this line as line of impact. We can say this as line of impact. So this line of impact is the line that is created by the collision between two particles. I assumed here, or I give here as examples, the ball 1 and ball 2 when they kick it from somewhere and they hit in between and they collide. So this is the basic principle and the definition about impact. Now on, we will see the types of impact. There exists types of impact due to depending on the position, directions, and magnitudes of velocities. There exists types of impact. Types of impact. Types of impact. Types of impact. So there exists types of impact. From those, the central impact is the main one. Central impact. Central impact. Central impact. Central impact. Eccentric impact. Eccentric impact. Eccentric impact. Central impact is the impact that is created by joining the line joint direct. By the way, this one is a central impact. There exists the line of impact is directly perpendicular to the plane, perpendicular to the plane joining the two particles. Note down. The line joining, line of impact is line of impact. Line of impact. Line of impact is perpendicular to plane of contact, plane of surface of contact, surface of contact. See this plane, and there exists the line, this line I told you, the line that connects the contact point and the center of masses of the two particles, that becomes perpendicular at some point, and that is called the central impact. Central impact. There exists also the categories of central impact. That's direct central impact. Direct exists a line joined by these points. So this is called line of impact. Line of impact. Line of impact. Line of impact. I have explained a line of impact. So it exists like this. Okay, so there exists also velocity here. There exists velocity of A, and there exists velocity of B also here. Velocity of B also here. Velocity of B also here for two particles A and B. So this is the point of contact. So in another view, it is the plane of contact. Or this point is the line in this view, and in another oblique view, it becomes the plane of contact. So this is the perpendicular. It becomes so, and the two particles match in the one single line of impact. That is, there exists. They have also a single line of impact. So as it becomes central impact, and specifically the direct central impact also, because when two velocities are when two bodies velocities are acting along the line of impact, and motion is purely unidirectional. Okay, purely one directional. By the way, in direct central impact, velocities are purely one directional. There exists the first velocity of A becomes in this direction. Velocity of B also becomes in this direction. So after maybe this velocity of A may be greater than velocity of B after somewhere. So if this velocity of A is greater than velocity of B, so it can reach somewhere. Or they collide in each other in somewhere, because this runs, the particle A runs as faster than B, right? B. So somewhere they collide and go with some uniform velocity. You can say some U you can assign. So they collide somewhere and they can go with some uniform and single velocity for both. So they go at in contact. So like this. So after somewhere also, if velocity of a and b also after collision, due to collision there is a force, right? There is a force. So due to that, one throws out and one goes back, one goes forward. So there also can be velocity of a is less than velocity of b, right? Velocity of b. So there is also the scenario that the linear momentum is conserved, and then is also the scenario that we apply the principles of impulse and momentum, and so there exists another equation derivations, and linear momentum and principles of impulse and momentums are also applied. So there exists calculations. See, and I will see attach these things on a description or another and another. The impact type is another impact type is oblique, right? Oblique, oblique impact. So in oblique impact, the when particles move away from each other with velocities having unknown directions and unknown magnitude. That means velocities are not parallel. Velocities are not parallel. Velocities are not. Velocities are not parallel. Are not parallel, right? Velocities are not parallel. Velocities are not parallel. This means it is also a central impact. Actually, it's a central impact. Velocity is not along the line of impact. What I am saying here, velocity is not along the line of impact. It is that. So motion has a component. There exists a components for a split of components in tangential and normal components. Centers are aligned, but motion is angled, right? Centers are aligned here, centers are aligned. Centers, or they're both centers, maybe center of mass, center of centers of masses of the particles are aligned. That is why we have said that it is the part of central impact. But here motion is angled. Motion is angled. So motion is along some varying angle, okay, in unknown magnitude and unknown direction due to the collision. So this is the oblique impact. When you deal about the eccentric impact, the line of impact does not pass through the center of the mass. Okay, when you deal about the eccentric, we have seen before also. When you see about eccentric, eccentric, the cause of rotation is there, angular motion is there after collision, both translation and rotational effects occurs, and line of impact does not pass through the centers of the mass. In eccentric, line of impact does not pass line of impact does not pass through the center of mass. So this varies in eccentric, but in oblique, centers center of masses are aligned, but motion is angled in varying unknown direction and unknown magnitude Okay, so note down these things, and for your more understandings, I will attach you a file in a description. Thank you.